Hello everyone. Let's look at today's Leetcode problem 3342. Find minimum time to reach last row number 2. This is a follow-up question or an extension to the previous questions that we solved yesterday. Before starting this problem, let us look at motivational quote for today. Failure is simply the opportunity to begin again, this time more intelligently, given by Henry Ford. So it tells us few things like we should never stop our journey in whatever we are trying to achieve, and whenever we hit with any sort of failures, we should never stop, or we should never break down and put a complete pause to whatever goals that we have, or whatever pursuit that we have. Take the next step, learn from your previous mistakes, and make the next step in a much more knowledgeable way so that you can proceed forward. But accept failures as a learning step. Okay, let's look at today's Leetcode problem 3342. Let's understand the problem statement and let's go from there. So, similar to yesterday's problem statement, there is a dungeon n comma m, rooms arranged as a grid. You are given a 2D array move time of n into m, where move time I comma j represents the minimum time in seconds when you can start moving to that room. You can start from the room 0 comma 0 at time 0, and you can move to the adjacent room. Moving between adjacent rooms takes 1 second for one move and 2 seconds for the next move, alternating between the two. So this is something that we need to take into account, and this is a change that we have from the previous problem. Return the minimum time to reach the n minus 1, n and m minus 1, the last room. Two rooms are adjacent if they share a common wall either horizontally or vertically. So we have given with this value moves time of I comma j. So we have this moves I comma. So let us look at this example and let us see if we can understand the output with this example. So 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 I am having to draw the same values here. Uh, the values here are 0, 4, 4, 1, and these are rows 0, 1, 1, 0, 1. So let's call this the index 0 comma 0 and 0 comma 1, and 1 comma 0 and 1 comma 1. So as we know, we start from 0 comma 0, and we want to move to the final index. This is the last room, and we also want to calculate what would be the best possible way to reach this last route. So in this case, let's say we can travel either through this route or through this route. let's see both of them. So let's say we start from 0 0 to 0 1. So here the time is 0 and the required time of wait time is equals to 4, and move time, let's call this move time, and we might end up at 5 seconds at this one. So once we reach 0 comma 1 or 1 comma 0, we would be having, similarly from 1 to 1 comma 1, if we need to go, then we know that time here is 5 seconds, and we also know that the time here is 4 seconds. So we are good to go to this one. So we can take the minimum of 4 comma 5, and sorry, so we can say 5 seconds is the elapsed, and this is the move time, which is 1 second, and totally we end up with 6. But 6 is not the one, so here we should be adding 2, as this is the adjacent cell where we added 1 here, and this would be 2. So it would be not 6, it would be 7, and that's the same answer that we see. That's right. So let's look at another example. Let's say this as an example 1, and let's consider this as an example 2, and here we have given with 0 0 0 0 and 0 0 0 0. So we can either go through this route or this route. Since all of them have the same value, let us consider one of the routes where we start at 0 comma 0, and to move to the next cell we take uh, 0 second plus 1, so 1, and once we are at 1 comma 0, that is this point, we take to reach to 1 comma 1, which is right here. So we would add up 1 plus 1, so this would be 1 plus 2, as this is an adjacent cell. And now moving to this row from this to this, so we can have 1 to 1 comma 2, which takes the value 3 here, time is equals to 1, and here it goes to 3, and let's say we have added 2 here, so we take up 1 as an adjacent one, so here it would be 4, and coming to the last value, 1 to 2, so 1 to 2 to 1 comma 3, so we are at 1, and I believe we should be adding 2 here, 1 here, and here we added 1, and 4 plus 2, so this should be 6, and this is the values that we see. right? So only thing that we want to do here is we want to alternate between 2 seconds between each adjacent move. So we can see that we can quickly identify a pattern that when we are moving from uh, let's say a 4 cross 4 array, and here to here we added 1, and here to here we added 2, and here to here we added 1, and here to here we added 2. So this comes out to 6. So one thing that we can see is this is 0 comma 0 and 1 comma 0, and this is 1 comma 1. Similarly, this is 1 comma 2 and 1 comma 3. So if we want to calculate what is the value or the move time that we want to calculate, so we can come up with a formula such as row plus column modulus by 2. And if there is a reminder, then we say, for example, in this case where, or let's consider this as a case where let's say we are at 1 comma 1, 1 plus 1, and it is completely divisible by 2. So we say this is an even index and we only need to add 1. While here, in case of this point, uh, when we are transition to the destination, let's call this destination vertex. So this gives 1, and we need to add this at, since this is an odd. So all we are trying to measure here is if this is an odd value or an even value, and that would give us the move time that we want to add. Okay, so let's see if we can solve this to in a similar way as our yesterday's problem. We will still be opting Dijkstra's algorithm. Uh, as we need to find shortest path, and we already saw why we won't be choosing a greedy approach. We know why we won't. We know we are not going with greedy approach. So we can take an example quickly to see why we can not be considering a greedy approach. Let's say we have 20 and this as at 25, while and this to be at 5, and all of these values here would be 100, and let's say this as 80, and this as 50, and this as 60, and let's say this as 50, 50. So let's say if we are greedy and if we go to this path, if we add up 50 and so if we choose between these two and we consider this as an highest value here, and we opt this path, we would be missing the minimum values here. So hence we wouldn't be choosing this approach where we get a lower value. So let's take a look. So for example, let's say we go from 20 to 5 to 50 to 50 and then to 50. We could even have a better approach where we go about 20 to 25 and 60 and to 50 and to 50. So yeah, in this case this solution works, but let's say if we have a value which is lower in number, let's say here uh, uh, 80 here and 10 here, uh, so this would change the whole dynamic of this problem, where let's say this might be swapped out with 80 and this can be changed with 10, which was previously 60. So this comes to a much lesser value, where 25 plus 80, 105 plus 100, 205 in this route. While if we go on this journey, then we be having 100 plus 45 plus 10, 165. So since we opted for the greedy approach here, we ended up with a much larger value rather than choosing what is the smallest distance, uh, where Dijkstra's algorithm would perform much better in this situation, finding the local distance between each node. Each vertex. So this is done much better in Dijkstra's algorithm. So we opt for this. And this was already explained in my last example as well. Okay, let's go to the Leetcode editor and let's try solving this problem. Okay, so here we are in the Leetcode editor. Before starting this, I have pasted uh, this specific class for having to use a min heap, and this has certain common operations such as push, pop, and size, and these are certain other operations which we do internally to shifting a value up or down. And yeah, and here we have our method. So let's see how we can implement our solution for this problem. So firstly, we will start out with creating few constant variables to store lengths of the array. And here we are creating a temporary array to store the best distance. And let's have a value filled with maximum safe integer, or let's say we can fill it with a value of infinity. Okay, so this creates an array of m cross n lengths and fills all of the values with infinity. And let's create a min heap. From the above class that we have written, and we can start out at the distance 0, and we can start updating the relative values of the shortest distance between each node. Let's initially push the heap with the first node, and let's say we are at 0th index and at the time 0. So from here, let's always keep checking if the heap size is greater than 0 as a cursive condition. And let's check if the distance at a specific vertex or an x comma y coordinate uh, is greater, and then we simply move out of, we continue with the same flow. And if this time is greater than the time that we have captured at a specific index in this best array, then we simply continue without having to replace or do anything. And let's loop over all of the 4 directions and find the best possible direction at each vertex. Let's put out certain boundary conditions where nx should be less than 0 and it should not exceed the final index value, calling it n as the length of the array. And here let's calculate the wait time. let's check if which of the values are greater. So let's check if the value at a specific index that we are trying to explore or the current time is greater. And let's say we need to wait to move to the next adjacent cell, and let's say we call this as a move cost to new adjacent cell. So we check it by x plus y, and we can calculate the new time by adding these two: wait time plus that of the move cost. I see. If we are less than 0, if the values are less than 0, then we simply continue, and we and we say we reassign the value of distance array, which would contain some amount of time. If it is less than if it's greater than the one that we have just calculated or explored, uh, the above set of calculations, then we assign the distance time to the new time, and thereby also keep dot push this new time for the specific x and y coordinates at nx and ny, and we continue to explore the next set of values from relative to this point, and we return -1 post the calculation. Okay, let's see if we can submit this solution and this works. As you can see, this solution gets submitted. Let's see the time, and to write the time complexity here. Time complexity would be O of nm and log of nm, as we have exploration on each of the vertex, and space complexity would be n comma m, as we have the nm as we are storing in heap. Alright, thank you. Please like and subscribe if you are liking my videos and found this video helpful. Thank you.